Hey everyone, so I'm Sean Corkum. I'm a senior engineer at Northwestern Mutual, and I'm that wacko that back in 2016 said, hey, why don't we run our SEM in Kubernetes? So, go through here and, oh no, button doesn't work. Literally doesn't.
Guys talking about cloud native.
Technical
Can't work the
difficulties.
slide remote. What? No.
Here we
Did
go.
you turn it on and off? Oh, yeah.
All right, so legal disclaimers moving along. So, take two. Let's try this again. Don't need to see that. So, today we're going to talk about running GitLab and GitLab CI in Kubernetes and some of the experiences that we've seen. So, as you guys keep moving towards your possibly running in Kube, you can learn from some of our experiences as we've found many little quirks along the way. Is it me? There's one button to push. Yeah. There you go. Too aggressive with it. So, thank you. Kubernetes, we all know it, love it. It makes life a lot easier when if you're trying to deploy an application that's highly available, running across multiple AZs, letting you auto scale as easily as load increases. If you're wondering if you should run GitLab in Kubernetes, yes, that's the short answer. Long answer, same thing. Yes, just do it now. So along the way, we started, like I said, we started back in 2016. Obviously, nobody was doing that back then, so there was no documentation. Things we had to keep in mind, a lot of people weren't using Kube yet. It was still pretty new. We had to make sure that we were, good neighbors within our cluster because it's a shared environment. We only had the omnibus container back then. We played around with a little building all the different parts from source, but after about a week of that going, oh my God, this is going to be a maintenance nightmare. I don't want to do that. We also had to make sure that we were planning for 2,000 plus users and more than 20,000 repos as we were going forward. And we wanted to make sure that we leverage as many AWS services that we could, just so we could pull some of the load off of the omnibus container to try and save some resources, because the omnibus container is a little resource hungry. I'm even pushing it light this time. There we go. So we ended up with kind of this hybrid architecture. Reason being, as we come across new little quirks, we'd have to roll back onto an omnibus. So what we see here is we've got our Kube cluster, and then we had to go with a multi-Redis environment. Just as we were kind of coming across things, we noticed that the load was high enough that we needed to spread it out. We were leveraging S3 for the artifacts, LFS, uploads, yada yada. We've got our Elasticsearch cluster, leveraging RDS for Postgres. And then we've got our lsyncd, or our Gitly servers, which also doubled as our NFS for the home directory GitLab pages. And those were two different EC2 nodes kept in sync with lsyncd. All kind of pretty straightforward stuff, as you would expect. We leveraged Route 53 into an ELB to get everything into the cluster. When we did come across a quirk and we had to fall back onto the omnibus on an EC2, just a simple little DNS flip, takes no time at all. We would leverage the omnibus as well for doing the backups. As our number of repos grew and our user base grew, the built-in GitLab backup function just wasn't fast enough because it's essentially just doing tar-c into a zip file and then copying it up to S3. So we had to kind of break that process apart and run a whole bunch of it in parallel to make sure that we could actually keep up. Would I do this if I was starting now? Somebody else is running the show now. No. So Well, this is what we had to do because it was 2016 and it was just kind of the option that we needed to do. If we were to start all over, I wouldn't go exactly that route. So this is where I say, learn from our experiences, the little quirks that we came across. One of the first ones, I have to give a shout out, I don't know if he's in the room or not, Lee Matos. He's one of GitLab's support engineer manager now, I believe, but this is going back a number of years. We happened to be on a call, about something else, and we're describing our environment at the time, and we said we were leveraging EFS. It makes sense. It's an NFS essentially. It's easily scalable across multiple AZs. We're like, oh, this would be great. Make life super simple. Keep going. And then he goes, wait, what version are you on? He's like, oh my God, you need to stop. Do not upgrade. On the next one, I forget what version we were on. GitLab was moving a lot of the Git functionality out of the Ruby gem that they've been using and more onto Gitly. This caused a huge issue with EFS when you had a large user base, as Gitly was able to access the data so much faster than EFS. EFS has to lock the file for just a brief second while it spreads it across the different AZs. It also has a hard IOPS limit of 7,900. I don't know if that's documented just yet. It may be now, but for the longest time, Amazon was very hush-hush about that. So, don't use EFS. Save yourself the trouble. Something else that we came across, Khayyam. This is actually not so much an issue with Khayyam itself, but we kind of shot ourselves a little bit in the foot at first. So if you're not familiar with Khayyam, it's Kubernetes IAM. It allows you to take an IAM role, attach it to a pod, and then use an annotation to allow your different pods to access an IAM role to get to different AWS services. So we were using it for things, like accessing S3 for like the uploads and artifacts and something. What happened was, because we're using the omnibus container, which is a little resource heavy, as load would build up, it would cause the Khayyam pod to flap because that didn't have a resource limit and request set on it. So we'd get these sporadic issues like, hey, why all of a sudden can't we upload something to artifacts? As we start going through our different logs, and we would see that container flapping. So Khayyam itself, not a bad issue, and actually I would highly recommend it. But make sure you follow essentially a general Kubernetes best practice. Set your resource limits and requests. You don't want to accidentally starve yourself out and cause this issue where it's something flapping real quick like that. Geez, this is touchy. NFS. And I know you're all thinking, what? NFS? You just install that and you're ready to go. Who in the room knows what the recommended system requirements are for a large NFS server? One guy. You're the first person to ever say, yes, I know. So if you're not familiar, NFS actually is very memory hungry when you have a lot of users. So you can get away with 32 gigs of memory, but it's recommended for at least 64. Yeah, exactly, wow. How this became an issue is I was trying to be a little clever and save money. Remember before I mentioned we had Gitly and NFS on the same EC2. So what would happen is, if we were working through an issue that we found something going weird with the Kubernetes deployment, and we're back on the omnibus, which is using the NFS, as Sidekick was still running in Kube, because that just pulls from Redis, it would be accessing the Gitly container running on that EC2. The memory usage would go up, and it was low enough that it would hit swap. And if you've ever tried to run NFS and swap, you know it is not a happy camper. It kind of falls over on its face and goes, yep, nah, I'm done. Which, obviously problematic if that is your source of all your data. So just to kind of recap a little of that, just say no to EFS. Don't try to be overly clever with your NFS. Don't make that mistake. And obviously, make sure to set your system resources and limits on Kube. Obviously, just a best practice. So things we're looking forward to moving into, this man's Helm Charts. So if you're going to start out and you want to run, yeah, Jason from GitLab's up front here. If you want to run GitLab in Kube, I would recommend just going from that. One of the big reasons is he's broken apart all the different elements. So you've got your web and API containers, you've got Sidekick off in its own container, you've got Unicorn and so forth. And because the individual parts aren't like I was having to do with the Omnibus container, just kind of turning them off in the RB file, they're much, much smaller containers, and they can auto-scale much, much faster. The Unicorn one takes a couple of seconds to come up, or if even less, a second or something. So your deployment will be able to react better as a user load increases throughout the day and go back down. It's also, if you want to do an upgrade, you're just changing one thing, redeploy, and there you go. Something else that we're looking at, touchiest button in the world, EKS. So for different compliance reasons, depending on your field, you may or may not be able to use EKS yet. There's some little stuff that Amazon's changing that we're looking forward to trying out. Reason being is cluster swaps are kind of a pain if you've ever had to deal with something with stateful data. And one of the issues we have right now is we'd really like our data to be highly available, which GitLab currently doesn't run in kind of a clustered mode yet. I know it's on GitLab's roadmap, but I'm just antsy. I want it now. So to get that highly available, something that we've been playing around with is Rook. You may have heard the cloud native or the cloud founder company or CNCF, thank you, this morning talking about and saw this logo pop up. Rook is from a company called Upbound, a startup out in Seattle. What it does is allow you to leverage Ceph or CockroachDB, NFS if you want, EdgeFS, and essentially attach that easily into easily to your pods. The reason I like the Ceph one, at least, is in kind of POCing it and testing, what are the file system benchmarks. With it spread across 3 different AZs using an i3 instance, our write throughput was about the same as a 5,000 IOP provision EBS volume. However, the read throughput was more than double. And if you're somebody that leverages the API really, really heavily for a lot of different reads and a lot of stuff like that, obviously that's going to be a big boost. With it being Ceph, that's able to run in a cluster, so your data is getting replicated across multiple AZs, which can help you towards your high availability. If an AZ goes down, which obviously it's not an often occurrence, but it can happen, or you just lose a node, your app's not going to go down. You can figure out a solution to get back to where you need to be, and your end users are never going to notice. So with that, I'm going to hand off to my coworker, Kyle here, and talk a little bit about GitLab CI.
Hey everyone, so let's talk about GitLab CI. This is from kind of the administration perspective. So if you're running your own GitLab and you want to run your own runners, I know I heard from Eddie earlier today saying that the performance of the ones on GitLab.com, running your own might give you a little bit of an edge. So that's maybe one use case. But really, there's all kinds of use cases, whether it's security controls. So let's talk about how you can run your own. So,
not just me.
I'll get this. All right. So when you go to the docs, like any good engineer, to set up your first runner, you're going to realize that there's a bunch of different executors. And if you're coming from like a Jenkins world, I talk to people all the time where they're like, well, hey, we adopted GitLab SCM, but we're still using Jenkins or something else for CI. And that's perfectly natural. GitLab has a little bit of a different nomenclature. So if you're used to like the master agent model, congratulations. If you've already deployed GitLab app, you've already solved half the equation because of that kind of one-stop shop mentality of GitLab. The command and control center of that CI is already taken care of for you. But you are still going to need to provide some worker bees, something to do the heavy lifting, actually run your pipelines. And that's what we're going to call the runners, or agents, if you will. So there's different flavors of these. I've shown on the board here from the docs, starting with your basic shell executor. They get a little bit more complex as you go. Ideally, you'd want to build on the shell, go to a Docker executor, and then eventually, as you start to scale your pipelines to, say, hundreds or thousands of projects, lots of users, hundreds of concurrent pipelines, You're going to really want to look at either the Docker machine executor or the Kubernetes executor, because those are going to give you auto-scaling. So here's what that can look like out in the cloud. On the left, I'm showing the Docker machine executor. In this case, you're going to connect back to your app. That could be either running GitLab.com, that could be your own hosted Kubernetes installation, or even just a plain old instance. It doesn't really matter. You can interchange all of these kind of concepts. But what's interesting about the Docker machine executor is that the runner is just provisioning other instances to run your workload. So whatever cloud provider plugin you want to provide, whether it's Azure, GCP, AWS, DigitalOcean, it'll go and build individual boxes to run your builds or each job. And you're going to get no concurrency in this situation. So every build is essentially going to get its own dedicated machine. You're not going to run anything in parallel. So that's kind of a trade-off you have to make. If you flip over to the Kubernetes type model, you've got a build or a job per pod. So we can get a little bit better concurrency. We can get a little bit better build density at the cost of kind of having some noisy neighbor interaction type issues. So also in this diagram, I've depicted that we're running the application nodes in the cluster separate from the CI workers. So that's not required, but we would consider it a best practice to put that blast radius isolation there, just so that if your CI jobs go off the rails, you're not necessarily going to take down your app or anything else running in your cluster. Oops. So I kind of covered some of these comparisons. Really, it's a trade-off of, what do you want in terms of build performance versus cost optimization and density. Complexity is also kind of an opinion, I guess you'll say. Kubernetes being a little bit more complicated, Docker machine being a little bit more simple. But that's really changing in the latest, with managed clusters and things. They're really starting to close that gap. So I mentioned how you can run, isolate your workloads. This is really the combination of Kubernetes concepts working in concert with your GitLab CI configuration. So the way you can achieve this is to use labels and taints and tolerations. So what we're going to do to achieve that is label our nodes with something that indicates them as ready to accept GitLab CI jobs. And then the complement of that is in our configuration, we're going to say, all right, all the pods that we build for our GitLab jobs need to go attract to that label selector. And that's what brings our GitLab workloads onto those nodes, separate from the application. But that's only half the equation. So if we also want to keep the application workloads off of those GitLab CI nodes, we need to apply a taint. And that's like a repulsion in Kubernetes to say, hey, stay away. We don't want other workloads running on our CI system. And then finally, the toleration says, oh, if you are a GitLab CI pod, you can run there. So these four concepts, the taint, the toleration, the node label, and the label selector are achieving that separation. All right, enough about how to set up GitLab CI. Let's talk about some cool use case where Kubernetes really shines, or the Kubernetes executor. Let's look at this contrived example. We've got a simple pipeline, but at the end of it, we want to deploy to some managed service. In this case, I chose S3. It doesn't need to be Amazon, doesn't need to be a bucket, but you've got some pipeline that needs credentials, some sort of privileged access, where you want to push whatever your build artifact is up. Say it's a static website, for example. The first way we could do this is with, say, a simple IAM user. So we generate a policy. We say what exactly that user can access. We lock it down to that bucket. We're going to get some kind of API key, essentially just a username and password. And we can store that in protected variables. So that's just a project setting. This is great. It's simple. It's portable. We can run it on any runner. And that's going to go from whatever scope we define it at, project or group scope, and we can use it anywhere. Downside of this approach is these are really static. I mean, how many folks here rotate their API credentials every hour? A lot of scoffing? Okay. Year? Maybe? Okay, I saw some hesitation. Okay, the point is these things remain relatively static. It's not the forefront of our mind. We're not trying to be malicious, but we just don't keep up with it if it's not automated. So a lot of people turn towards role-based authentication. So like in the AWS, we're looking at instance profiles. We can assign this to a runner, and now the runner becomes a privileged entity, essentially. We've got a policy that's attached to the runner. Now we're getting automatically rotated credentials. So this is, we're boosting our security posture a little bit. Someone can still inject or grab this out of the environment. They can curl the metadata service and run off with your key. But but it's time bound. That's only good for a few minutes at a time before it gets rotated. So at least we're reducing that risk profile. The great thing here also is that the API call that a developer makes is the same. We haven't had to change our pipeline just because we switched the security model. Now, the real drawback to this solution is that if we make the runner a privileged entity, we essentially need a runner per project or per security domain. This gets really unscalable. So if you look at how this works out, I mentioned we were or Sean mentioned, thousands of projects, hundreds of groups, even bigger and growing. We're not going to want to have a runner per project, per security profile. It's just not reasonable to maintain that many runners, a lot of wasted resources. So that kind of leaves us at this impasse. We've got one solution that's secure, one solution that's scalable. Where is the happy medium? So how can we get both of these things and have our cake and eat it too? All right, so Khayyam, that Sean mentioned before, is one way we can achieve this sort of beautiful balance. The two key takeaways from Khayyam that you want to remember is it's a way to treat pods like an instance profile, or kind of give an instance profile to a pod. And then also it can be controlled through annotations. So we're going to use this and stitch it into our GitLab CI configuration. And now that same policy that we either applied to a user or an instance profile, we can now attach at the pod level. So rather than an instance having a dedicated build, now a pod is dedicated to a build. And a pod has its own security domain. So as we kind of connect the dots here, we're taking a GitLab project, giving it a policy. That project is going to get attached to a role through either its ID or its namespace or whatever convention you want to establish. And then in the configuration, we lock it down so users can't create those annotations. The GitLab CI configuration generates that annotation and then applies it to the pod, which gives it its security credentials. And these, again, are the kind of auto-rotating credentials we get with an instance profile, where these are time-bound, rotating, and limited to our risk profile. Again, same API call, same command line call for a developer to use. So what we've done is we've cut out the bottom mess of runners. We can still have the same common runner, the same Kubernetes executor, and then use that across all of our pipelines, but we're still maintaining siloed security domains. So you still have unique policies, but you can still use the shared runner architecture. We're getting that balance between security and scalability using Kubernetes. All right, so I kind of ranted about policies and all that kind of stuff and annotations. At the two ends of the spectrum, the things you need to remember are you had a policy attached to a project. All the stuff that happens in Kubernetes, that's abstracted away from your developers. At the end of the day, what you really end up with is a simple policy, and you come away with using the same API call consistently. You don't need to change your developer strategy just to up your security game. So that's a huge win. Usually I think of security as kind of a zero-sum game with developer productivity. In this case, we were actually able to boost our security posture and really not impact the developer at all. So that's a pretty big win in my view. So I'll open up for questions. I know that was kind of quick, but yeah, anything related to this or running the GitLab app on Kubernetes, it's all fair game.
So the Khayyam pod, right? Does that have to get all permissions, or do you give it like IAM pass role and then somehow passes it to the bots? Like, obviously something somewhere has to be given an IAM permission.
Yeah, so the nodes themselves, the Khayyam kind of handles that in the background. There's a client-server model where it's refreshing credentials, and it had the nodes themselves have pass role, but then you define a very specific policy just for that pod to inherit.
Okay, but like does Khayyam have to run on like a node that has a specific role assigned to it? That's just like God mode, so to speak, and hands out what you request?
Yeah, so the way Khayyam works is typically you run the servers on your control plane, and then there's clients on the worker nodes. So the control plane is privileged, but none of your workloads run there, except for the control plane itself. And that's how you create isolation between the privileged nodes and the ones that are handing the credentials, and then the client server brokers that and kind of creates a boundary.
But that control plane itself gets like a
Gets privileged.
Like it gets everything.
Not necessarily everything, but it would have ability to assume any of the roles that Khayyam is getting.
Okay, got it.
Yep.
It sounded like you said Amazon EKS is coming soon because of the support for high availability for Italy.
No, so they're for compliance reasons not worth really getting into right now. We're just not able to use it. But Amazon themselves is making a change that will allow it to be compliant for our industry. And so we're looking forward to being able to play with that versus a roll your own kube cluster.
I see.
Yeah.
So it's not supported at all right now for AWS.
No, just for our specific use case. This is something unique to us. If you wanted, there's no reason you couldn't go out and use EKS. In fact,
We'll
there's
let
a man that could
GitLab
even answer it
correct
better.
Let me interject slightly. All major cloud providers are supported by the GitLab Helm Charts.
Yeah.
There are instances in certain industries or aspects of regulated that you can't use certain cloud providers because things haven't passed for whatever reason. That's the hiccup that they ran into, is that currently they can't use EKS for that. We have other customers who can't use AKS yet. To your question of Gitlab, that is roadmapped and soon,
Yeah.
but that's another topic that I can discuss with you later.
Yeah. I know I saw one down at the end here.
And just real quick, also Jason would be a great resource for that. Also, James Ramsey, who's local, is back there. Would love to talk to you about GitLab. He's our product manager for all things GitLab. So make sure he knows how important GitLab HA is. Sorry.
Are you building Docker containers in your runners? And if so, are you doing that in your Kubernetes runners, and how?
Right now we're building our Docker containers with our Docker machine runners. We're not doing it in Kubernetes, but I was looking at some projects. I know Google has one out there, and there's a few that allow you to basically emulate and not run in privilege mode. So that's the risk that's preventing us from doing that right now.
The previous talk in this room, which will be published, was about doing exactly that. So
Yeah,
there's options for that.
awesome.
Any other questions? Great. Thank you, gentlemen, so much. We really appreciate it.
Thanks everyone.
Thank you, guys.